All right, so it's a little bit late here, and I'm itching to get nerdy with this statistics and Excel. So I have this question here, and let me clear this out just because I was just messing around and all this good stuff. So in this problem, it says a simple random sample size n is equal to 81 is obtained from a population whose mean is 73 and whose standard deviation is 27. So what we need to do here is we have 4 different tasks we need to identify. So we want to describe the sampling distribution of X bar. So in this case, the sampling distribution of X bar is what we're looking at in part A here. And since our sample size is greater than 30, we can say that the distribution is approximately normal, because the larger your sample size, the more that's going to get to approximately normal distribution. Now, this is where we're going to get a little bit nerdy, okay? So when we're talking about mean and standard deviation of a sample, the sample mean is going to be equivalent to the population mean. So if we go back here and look at our mean here, it's going to be 73. However, our sample standard deviation is going to be a little bit different. So the sample standard deviation is going to be equal to the standard deviation of the population divided by the square root of the sample size. So in this case, our sample mean is 73. So what I want to do is I want to show you how to construct a formula in Excel that helps you do some of this work. And then the population mean in this problem is going to be 73. And one other thing that we need to add here is sample size. So if you want to take a minute and pause the video, what you can do is you can fill out a table of your own using Excel or Google Sheets, and it's going to provide you with something fairly similar. So here we are going to write a formula. And anytime you're writing a formula in Excel, you want to start with the equal sign. So what we've got going on here is we need to have the standard deviation of the population, and that's going to be in your numerator. So the, oops, hang on. I meant to say sample standard deviation. So let's population. All right, let me clarify this a little bit. Let's see. We're going to say that's the sample mean. We're going to say that this is the population standard deviation. And then in this case, the standard deviation was 27. So in order to calculate the sample standard deviation, it's going to be equal to the population standard deviation divided by the square root of, let's see, SQRT, this right here. So let's double check this and see if it works out. Perfect. So the sample standard deviation in this case is going to be 3. So if we look at this formula, C2 is going to be the population standard deviation, which goes in the numerator of this formula, and then square root of D2, which is the population size. Now if we change the population to say 36, or the sample size to 36, we're going to have a different sample standard deviation. So we want to, even if we went to 144, it's going to decrease the standard deviation. And then if we did say 400, it's going to get smaller and smaller the larger the sample size is. So in this case, our sample size is 81. So the sample standard deviation is such. Now, the next thing we want to do is we want to calculate the z-score. So I have a formula here. So in this case, z is equal to x, which is the value that we're looking for, minus the mean divided by the standard deviation. So we're going to use this formula to do some work here. Now, let's go ahead and just put in 3 there and then keep moving on. So this is where we really need to dig into the whole notion of z-scores. Z-scores represent the cumulative probability of the sample or the population that you're working with. So in these situations, we're looking for the probability, in this case, that your X bar is greater than 77.2. So if we think about it, if we go to, let's see if I can get a visual here, Z-score. So if we look at this curve here, this will give you a representation of the various z-scores. So when z is equal to 0, that's the mean. So 50% of the data is in this purplish area, and then 50% of the area is, or 50% of the probability or the area is in the right-hand tail after the mean. So if we talk about cumulative mean, we essentially are adding up all of these different probabilities up until whatever your stopping point is. So if we go back to this question, it's looking for what is the probability that your x bar or your sample value is going to be greater than 77.2. So in this situation, what we need to do is we need to calculate the z-score and find the probability for this particular value. After which we are going to find the complement of that, because we are looking to the probability to the right of this particular value. However, let's go back to this formula here. It's going to be z is equal to x minus your mean divided by your standard deviation. So in this case, our sample standard deviation is equal to this value right here. So if we click equal and type in B3, anytime we adjust this, it'll change in this formula. So essentially what we're doing is we're constructing a formula that can be replicated over and over again, okay? And then the mean is going to be equal to the sample mean or the population mean. And then in this case, our x value is the one that we want to modify. So the x value in this case is going to be 77.2. So 77.2. Now if we're looking for the z-score, it's going to be equal to your x value minus your mean, and then we're going to divide that by your standard deviation. So since Excel is kind of finicky, I tend to put parentheses to ensure that the order of operations are followed in the way that they need to. So here, this tells me that with the x value of 77.2, that has the equivalent z-score of 1.4. So what we're going to do is we're going to find the z-score chart, and then we're going to find the positive z-score chart. So our z-score is 1.4, which tells us I'm going to go down to 1.4 in this column right here. And the cumulative probability of a z-score of 1.4 is going to be 0.9192. So the probability is 0.9192. Let me just confirm that I read that correctly. 0.9192. Perfect. So this is the probability of x, or probability of 77.2. Well, essentially it's x is less than 77.2 because we're looking for cumulative probability, and that's the values that are represented in our z-scores. So in this case, if we're looking for what is the probability that it's going to be greater than that score, what we need to do is we need to take 1 and subtract this value from that, which gives us a decimal of 0.0808. So 0.0808. So again, x in this case, x bar is going to be greater than 77.2, which is the complement of the z-score, or the probability that it correlates with 77.2. And really figuring out how to determine what we do, requires us to dig a little bit deeper into the text and how things are written. Here's something a little bit different. So we're looking for the probability that x is less than or equal to 66.4. Now, since we're looking for x is less than 66.4, we're looking for the probability to the left of that value. So what we can do is change our x bar, or x value, to 66.4. And if you notice, this 66 is less than the sample mean, which means it's positioned to the left of the mean, which tells us we're going to have a negative z-score. So in this case, we have a negative z-score of negative 2.2. So if we have the probability that x is less than or equal to 66.4, we have a z-score, so probability that x is less than or equal to 66.4. We have a z-score of negative 2.2. So if we go to a negative z-score chart, we're going to be able to find a negative 2.2. So we look here on the left, negative 2.2, and that gives us a probability of 0.0139. So that's what we're going to put in here, 0.0139. And it says round to 4 decimal places as needed. Okay? And if we're moving too fast, if you want to go and pause and do this work, you totally can. And then this part D is going to be a little bit tricky because really what we're doing is we're looking, so let's see, 2 z-scores. Let's see if I can get a picture of what that could look like. Okay, so this right here is an example of what we're looking for. So if we're looking for the probability that it falls between 2 z-scores, we need to find the upper limit. And we're going to take this cumulative probability and then we're going to subtract the second cumulative probability that's associated with that second x value. So essentially, to reiterate what I'm saying here, we're going to take this probability for the larger value, and we're going to subtract the probability from the smaller value to get the shaded region here. So in this case, we have a lower value of 71.35. So we can change this to 71.35. And we have a new z-score of negative 0.055. So z is equal to negative 0.055. And then we have an upper value of 80.05. So if we put 80.05 here, oops, that's 0.65. So the z-score that correlates with that one is going to be 2.35. So that's a pretty wide gap. So 2.35. So what we need to do first is find the probability of a negative 0.55. So we'll do the negative z chart, negative z-score table, and we're doing negative 0.55, which is kind of funny. It's right here. So 0.29116. So 0.29116. Make sure I did that right. And then if we go to our positive z-score table, we're going to have a z-score of 2.35. So if we go here, we need the positive version, maybe. So 2.35, we're going to go down to 2.3 here, and then 2.35 is going to be 0.9906. 0.9906. So essentially what we need to do is we need to find the difference between these two values. So we're going to click equal, click the largest one, minus, and then we're going to click the smallest one, and it gives us a probability of 0.6994. So 0.6994. Fantastic. So again, a lot of this work really boils down to identifying your key values, which is going to be your sample size, your population mean, and then your population standard deviation. Once you find those values, you need to find your sample standard deviation and your sample mean. The hint here, sample mean is going to be the same as the population mean if it's normally distributed. And then after that, you really need to find the z-scores that correspond with the given x values. And then looking at the question, you want to determine whether or not you are looking for cumulative value, that is x falling to the left. And then if that's the case, you're going to stick with the probabilities that are given within the z-score table. But if you're looking for the probability that x is greater than a given value, that's where you're going to want to find the complement, where you're essentially finding the probability that corresponds with the z-score for that given x value. And you're going to subtract that from 1 to get the right-hand test on that one. Anyway, this was longer than what I anticipated. Hopefully it was helpful. Let me know if you have any feedback, and we'll keep cranking.